Hello and welcome. In this video, we'll talk about the symmetry of functions. Remember, this lesson is a continuation of lesson 1, Introduction to Functions, where we spoke about the definition of a function and the terms dependent, independent, variable, xy notation, function notation, domain, range, continuity, and intervals of increase and decrease. So, first of all, when we talk about symmetry of functions, we talk about the symmetry of the shapes of their graphs. There are two types of symmetry that we observe. One is the even symmetry and the odd symmetry. So we call them for short even functions when they have even symmetry and odd functions when they have odd symmetry. In an even symmetry, we see that the graph of a function is symmetrical about the line x equals 0, which is the y-axis. Now, what happens in such graphs? As you see, if you folded the graph or the paper, if this was to be on a piece of paper, along the y-axis, you will see that the two halves or the two parts of the graph will overlap. So they will become one. From the algebraic point of view, we're going to say that the values of y on opposite sides of the y-axis, which means opposite x values, will be the same. For example, according to this graph, f of 1 is equal to f of 1 equals negative 1. There you go. F of 1 is negative 1. And f of negative 1 is also negative 1. So at x equals 1 and negative 1, the y value is the same. So at two opposite values of x, the value of y is the same. So if you look at x equals negative 2 and positive 2, you see that the value of y is again the same, 2. And the same thing with the points where x equals negative 3 and positive 3, the y values are the same, 0. So therefore, we are going to say that if f of 1 and f of negative 1 are both equal to negative 1, then f of 1 equals f of negative 1. F of 2 equals f of negative 2. F of 3 equals f of negative 3. In general, then, we're going to say that f of x equals f of negative x. Again, remember f of x is just another name for y, and it seems that the y value at x is the same as the y value at negative x. Now, an odd function or an odd symmetry function is rotationally symmetric about the origin. So what does that mean? So if you have this point in here, I'm going to mark this by letter A actually. If we have this point and we rotated this point around the origin 180 degrees, that will go right here at this point. So the points A and let's call this one P will overlap, so they will be the same at the same spot. They will be located at the same point. So what does it happen then in from the algebraic point of view? So I'm going to I've chosen some points in here, and we're going to look at them together and define the values of y at the given x values. So at x equals 1, we see that y equals 2. At x equals negative 1, y is negative 2. So we'll say that f of 1 is not exactly equal to f of negative 1, and that's because of the negative sign in here, but it will be the opposite of f negative 1. At x equals 3, right here, we have the y value negative 2. Oops, I want to choose. And at x equals negative 3, the y value is negative, oopsie, at x equals negative 3, the y value is positive 2. So right here. So we're going to say that f of 3 and f of negative 3 are not exactly equal to each other. They are opposite in value. So we're going to say that's negative. And at x equals 5, we have the value of y slightly lower than negative 3 here, as you can see. Around negative 3 actually. And at 5, we have positive 3. So we're going to say that f of 5 is negative 3. And f of negative 5 is positive 3. So notice that the y values will be opposites of each other. Right? So one will be 3 and the other negative 3 at opposite values of x. So for short, we're going to write here that f of 5 and f of negative 5, so these two y values are opposites of each other. In general, we're going to say that in odd symmetry functions, f of x equals the opposite of f negative x. Now, some people and some teachers in the meantime, and some textbooks even, like to reformulate this differently. So negative f of x equals f of negative x. So don't be surprised if you see this. It's just another variation. You've just divided by negative 1 both sides of it. I prefer myself to keep the negatives both in the same side of the equation. Okay, so it's easier for me to remember that in odd symmetry functions, f of x will be the negative f of the negative x. So we have two negatives on the same side. And once you decide which method you prefer, always stick to it, because sometimes mixing them up can lead to getting the wrong answer. So we're going to take a look at some equations of some functions, and we have to make a decision whether the function is even, odd, or neither. We're not going to graph them. We're going to look at them from the algebraic point of view again. So the first thing I like to do usually is check and see if the function is even. So if the function is even, I know that f of x must equal negative f, must equal f of negative x. Goodness. And if I don't see this happening, I check and see if it is odd by simply adding a minus before negative f of negative x. And if nothing happens, that means that is neither even nor odd. So let's get started with the first example. First of all, I'm going to start with f of negative x. F of negative x means that instead of x, now we have negative x on the right side of the equation. We'll replace x by negative x. So we'll have 2 negative x squared minus 3. The next thing I want to do is simplify. So negative x squared is positive x squared minus 3. And now that I have simplified completely, I'll take a break, a deep breath, and I will try to compare f of x with f of negative x. Do they equal each other? It seems they do, which means that f of negative x and f of x are equal. So we'll say that f of x equals f of negative x. Therefore, the function has even symmetry. Okay. If you were to graph this, then you would see that this would be a parabola that has been translated 3 units down, and it's a thinner parabola compared to the basic parabola because it's vertically expanded by a factor of 2. So this number 2 before x squared. You can see from the graph that once you fold it along the y-axis, the two sides of the graph will become 1. Let's move on to the next example. Example 2. In example 2, we have g of x equals negative 4x squared plus 3x minus 2. As I mentioned before, I will start by finding g of negative x. So it will be negative 4. Instead of x, I'll write negative x in the other side of the equation, plus 3, oops, I see x again, so negative x and then minus 2. So simplify, negative x squared is positive x squared, so negative 4x squared minus 3x minus 2. So that's g of negative x. So I'll take a break now, and I will try to compare the equation or expression that represents g of negative x with g of x. And I see that the first terms are the same. That's great. The last terms are the same. That's awesome. But the middle terms are not exactly the same. So that's enough for me to say that g of x is different than g of negative x. Therefore, the function is not even. But I won't stop there. I want to check if it is odd. So for a function to be odd, then I need to find negative g of negative x. So what that means is that I'm going to grab the g of negative x here, and I'll give it a negative sign, the whole expression. So there goes the negative sign. And here goes my g of negative x, which is negative 4x squared minus 3x minus 2. I will multiply by this negative sign every term inside the brackets, and that will change to become 4x squared plus 3x plus 2, and that will be negative g of negative x. And this is when we stop again, and we try to compare negative g of negative x with what we were given. And we see that the first terms are opposites of each other, so we are looking for exact same expression. So we want g of x and negative g of negative x to be equal. So the first two terms are not the same thing, and that's enough for us to stop examining it and make a decision and say that g of x is different than negative g of negative x. So that makes the function not odd either. So if it's neither even or not, that means that we say it's neither. Sorry, I'm writing them kind of randomly. I should have given myself more space when I made the worksheet. So moving on to the next example, we have h of x equals negative 2x cubed plus x. Again, as I mentioned before, we are going to start with h of negative x. So we're replacing x by negative x as indicated in function notation. So on the right side, wherever we see x, we'll replace it with negative x. So we have negative 2, negative x to the power of 3, plus, okay, I see x again, so negative x. So negative 2. Now negative x to the power 3, since the exponent is odd, will give negative x cubed. Plus minus x is minus x. We have two minuses multiplying each other, so that will make a plus 2x cubed, and then minus x. So we're going to say that h of negative x is 2x cubed minus x. And now it's time for us to compare h of negative x with h of x. Check and see if they are equal. If they're equal, then we'll say the function is or has even symmetry. So negative 2x cubed is the first term in h of x, 2x cubed in h of negative x, so not even. We're going to say that h of x is different than h of negative x, therefore it's not even. Now let's check and see if the function is odd. So for this, we will need to compare f of x with negative f of negative x. Negative f of negative x. Now negative f of negative x equals negative, so here goes the negative. And then we have f of negative x, 2x cubed minus x, so that will give negative 2x cubed plus x. So that would be our f of negative x with a negative in front of it. So now we have to compare the two expressions that represent each function, and it seems that negative 2x cubed plus x, which we just got here, is the same as the given function, and that tells us that h of x is the same as h of, I made the classic mistake here, sorry about that. So I should have stuck with the letter h in here, obviously, because we are talking about an h function. That's the name of it. Doesn't affect our answer, definitely. So it's a matter of honoring our the names of our functions, right? So they are the same thing. So we'll say that h of x equals negative h of negative x, and that will make this function odd, very odd. Okay, so moving on to the next example, and by all means you may stop the video and try to do that on your own. We have y equals 4x4 plus 1. So notice how it is kind of more difficult now that the function is in xy notation for us to describe or to show the solution or algebraic explanation of even or odd symmetry. So I'll give this function a name, g of x, and I left this on purpose just so that I could give us an example of how function notation is more convenient to use. So I'll start with g of negative x. So replace x by a negative x. It's power of 4. Goodness. And here we go. We get 4x to the 4 plus 1. Compare the function we just obtained with the given function, 4x squared plus 1. We'll say they are the same. So g of negative x and g of x are similar, and they are exactly the same. So then we're going to say g of x equals g of negative x, which will make this function even. Okay, so the last example is g of x equals 2x cubed minus 2. By all means, try that again. And you probably have thought about the fact that usually when we have odd powers, that's when we most likely will encounter an odd symmetry. If you have thought that, that is true. We cannot find even symmetry graphs in odd degree functions, and this is an odd degree function. But also remember that not every odd degree function will have odd symmetry. Okay, so 2x cubed minus 2, I'm going to start with g of negative x, which is 2 times negative x cubed minus 2. So that would equal 2 times negative x cubed minus 2. And even more, negative 2x cubed minus 2. That would be g of negative x. And if we compared it with, I'll rewrite it better. Sorry about that. Is negative 2x cubed minus 2. So if we compared the function we just obtained in here, negative 2x cubed minus 2 with the given function. We see they're not exactly the same, so we're going to say not even. So we have to check for odd. So we're going to do that by finding the opposite of g negative x, which is negative 2x cubed, negative 2 plus 2. And we're going to say that in this case, we won't again have, oops, let me try it one more time. So it tells us that we do not have the same function again, so neither even nor odd. So we're going to write neither here. Okay, and again, as I mentioned before, just because a function is an odd degree function doesn't mean that it has odd symmetry. So try to separate these two concepts from each other. So I hope this all made sense, and I hope you enjoyed the explanations, and I'll see you next time. Bye for now.